Our planet is constantly communicating, sending out subtle signals. Here at the GeoCosmo Research Centre, our job is to listen and try to understand that language. Today, we're going to share the story of one truly incredible anomaly, a story that starts with some very strange clouds, but ends up taking us deep inside the Earth's crust.
Let's take a trip back in time to October 26, 2016. What you're looking at here are the skies over central Italy. Now, at first glance, it might just look like a normal weather pattern, right? Well, our data told us something very, very different. This, it turns out, was a visible warning sign of a powerful earthquake that was just hours away.
So how in the world did we connect these specific clouds to an earthquake? Well, it all began when our team spotted this really peculiar cloud formation on our satellite feeds. It didn't fit any of the models. It didn't look like weather.
And here's how it all played out. At 5 p.m. Universal Time, you can see the skies are pretty much clear. But just 1 hour later, a strange cloud mass appears, seemingly out of nowhere. By 7 p.m., it's grown dramatically. But here's the real kicker. By 9 p.m., hours later, these clouds hadn't budged. They were just sitting there, completely motionless.
And this is the view that really got our attention. You can see all the surrounding clouds in the area are moving along normally, just drifting with the wind as they should. But that one specific mass, right over central Italy, was stubbornly locked in place for hours. And that's just not supposed to happen. That was the clue that told us something else was going on.
Our atmospheric analysis was absolutely conclusive. This behavior didn't match any known weather phenomenon, like a stationary front. It had to be a non-meteorological event, and that meant we needed to look for a non-meteorological cause. We had to start looking down, into the Earth, instead of up at the sky.
And then, just as our team was watching this bizarre atmospheric disturbance get bigger and bigger, the unthinkable happened. The ground directly underneath these clouds began to shake. The timing was just too perfect to be a coincidence.
At 1900 Universal Time, our satellite data showed not only that the cloud mass was growing, but also that the signal for air ionization was peaking. And right as this atmospheric signal was hitting its absolute peak, the first seismic event happened. 10 minutes later, at 1910, a magnitude 5.5 earthquake hit. And the location? It was incredibly precise. A shallow depth of only 9 kilometers, directly beneath the area of those stationary ionized clouds.
But it wasn't over, not even close. Just 8 minutes after that first shock, at 1918, an even more powerful quake, a magnitude 6.1, struck the very same spot, coming from an even shallower depth of just 8 kilometers. The connection was undeniable.
So this perfect, almost minute-by-minute timing between the clouds and the quakes led us to a really fascinating question. How on Earth can stressed-out rock deep underground actually create clouds up in the sky? This is really the heart of our research.
I mean, it's a pretty wild question, isn't it? And the answer, it turns out, isn't really geological in the way we usually think. It's electrical. The key is a very specific kind of charge carrier, something that lies dormant, hidden within the rocks themselves, just waiting for the right conditions to wake up.
Our research, which actually builds on foundational work from NASA, points to something called positive holes. Now, the easiest way to think of them is as dormant little pockets of electrical energy that are trapped inside rocks. When tectonic plates squeeze those rocks with incredible force, it's like flipping a switch. These charges activate and start flowing like a current, right through solid rock, at unbelievable speeds.
So here's how the whole process works, step by step. First, you have deep tectonic forces putting immense stress on the rock. Second, this stress activates the positive holes and they start to flow. Third, they literally race upwards through miles of solid rock to get to the surface. And finally, they shoot out into the atmosphere, where they electrify or ionize the air molecules right above the ground.
Okay, so you might be wondering, well, if this is happening, why don't we see these earthquake clouds before every single earthquake? And that's a great question. It's because this phenomenon isn't a given. Our research shows that 2 very specific conditions have to be met for these special ionized clouds to actually form. First and foremost, the starting point of the earthquake, what we call the hypocenter, has to be relatively shallow. If the stress is happening deeper than, say, 30 or 40 kilometers, the positive holes just run out of steam before they can reach the surface. There's just too much rock for them to travel through.
And this slide shows that principle perfectly. You can see the charges from a shallow quake have a clear path to the surface, and they can ionize the air, but from a deep one, they just can't make it. The quakes in central Italy were so shallow,
They were basically the ideal candidates to create this exact effect.
The second critical ingredient is simply water vapor. You need high humidity in the air. We're talking over 75%. These brand new ionized air particles act like tiny little magnets for water, causing the vapor that's already in the air to condense around them and form a visible cloud. Put simply, if you don't have enough humidity, you won't get a cloud.
And it's really important to note, this isn't something that's only happening in Italy. Researchers in Japan have been documenting these same kinds of earthquake clouds for years. It's all part of a growing body of evidence from around the world that suggests this phenomenon is very real.
So what does all this mean? What's the ultimate significance of this research? Could this change how we understand and maybe even one day anticipate earthquakes?
Okay, so let's just quickly recap the key takeaways here. We've seen how massive stress on rock can release these electrical charges called positive holes. We've seen how these charges can race to the surface and ionize the air. And if the conditions are just right, a shallow quake and high humidity, these incredible stationary clouds can form. This is the exact sequence we observed, hour by hour, before the 2016 Central Italy earthquakes.
Now, we have to emphasize that this is a developing field, and a lot more research is needed. But these findings, they open up a provocative and really exciting new path for study. They suggest that to understand the immense forces at work deep beneath our feet, maybe we also need to remember to look up. The sky, it seems, might be holding secrets that we are only just beginning to unlock.